Hello, this is 6th grade Engage New York Model 1, Lesson 3, Part 2, continuing what we did yesterday. So we're going to start with exercise number 4 on the classwork about Josie. Josie took a long multiple choice end of the year vocabulary test. The ratio of the number of problems Josie got incorrect to the number of problems she got correct is 2 to 9. That's the general information they're giving us for question number 4. So incorrect questions to correct questions, the ratio is 2 to 9. A asks, if Josie missed 8 questions, how many did she get correct? Draw a tape diagram to demonstrate how you found the answer. Now, as we talked about yesterday, the most important thing to remember about tape diagrams is that it must match our ratio. A lot of times we hear the other numbers, like how many questions she missed or the total number of questions, and it distracts us from the proper way to write our tape diagram. So when you draw your tape diagram, it has to match the ratio. 2, 3, 4, 5, 6, 7, 8, 9, and 2. So here's my tape diagram for incorrect and correct. Now, it tells us Josie missed 8 questions. So if she missed them, did she get them incorrect or correct? She got them incorrect. And that equals 8 questions. So I know 2 of these units equals 8 questions. So if the total of the 2 units are 8 and they're equal units, what is the value of each unit? The value of each unit is 4 questions. 4 plus 4 is 8, so if they're both worth 4, in all she missed 8 questions. Now that I know the value of the units, I can calculate how many questions she answered correctly, because all of the units are equal. Now, I can choose to do repeated addition and 4 plus 4 plus 4 plus 4, or I know there are 9 units with 4 questions in each unit, so 9 times 4 is 36. Josie answered 36 questions correctly. That is how you use a tape diagram to solve a question with ratios. Now, based on the same information with Josie, they ask question B. If Josie had missed 20 questions, how many did she get correct? Draw a tape diagram to demonstrate how you found the answer. So now she has missed 20 questions. How should I draw a tape diagram to know how many she answered correctly? Not to be distracted by the 20 questions, your tape diagram should always match the ratio. So I'll draw 9 units. And 2 units. Okay, so on this question it tells me that she got 20 questions wrong or incorrect. This is my ratio for incorrect to correct. So now 2 equal units must add up to 20 questions. So if they're equal amounts, how much would each unit be worth? Okay, if you said 10, you are correct. They have to be the same value in each unit, and it has to add up to 20, so the only answer would be 10 questions. So now I know all of the units are worth 10. And again, I can choose to do repeated addition, but I know there are 9 units with 10 questions in each unit, so I know that Josie got 90 questions correct. And that is how we would solve this question about Josie using a tape diagram. Okay? For C, they want to know one more thing. what ratios can we say are equivalent to 2 to 9? So they gave us the ratio of her incorrect to correct with 2 to 9. Based on these tape diagrams, we were able to come up with 2 more ratios that are equivalent to 2 to 9. What are they? If you said 8 to 36, that is correct. And if you said 20 to 90, that is correct. Now, there's one important thing that you need to know. It will help you with the homework assignment. Go ahead and look at the problem set or the homework assignment for lesson 3. At the top in the box, it gives a lesson summary. This can be kind of confusing for you, so I want to take a second to go over it. 2 ratios, A to B, and C to D are equivalent ratios. Now, we don't have any ratios that are A, B, and C, and D. All of our ratios are given a number value. Why? The reason that they're telling you ratio A, B, and C to D is because they don't want to give you a number value. They're saying all ratios that are set up have one number and then a different number, usually. They use different letters so that you don't think the numbers have to be equal. And so these are 2 ratios with all of the numbers being a different value. Just like if we took into consideration 2 9ths and 8/36. These are 2 ratios and all of the numbers are different. That's why all of the letters are different. Now it says these ratios are equal if there's a positive number called C. This is a lowercase c. And so this can be any positive number, such that capital C equals CA. This looks a lot like algebra, and it should because these are pre-algebra skills that you'll use later in life, but it's not as difficult as it might seem at first. When you have 2 letters together like this in math, it means you're going to times them together. So we're going to take A because it's talking about that first number. So in this case, it's 2. So A is equal to 2. 2, and they're right together, so we're going to multiply it by a number to get C. And in this case, our C is 8. So 2 times what number equals 8? 4. So this little c is equal to 4. So 2 times 4, A times C equals capital C. And then it says such that D is equal to that same value times B. Our B in this case is 9. So we have 9 times the little c, which is 4. And 9 times 4 is 36, which gives us our new value of 8 to 36. So A to B is 2 9ths. C to D is 8/36. We know these ratios are equal because you can multiply them A and B by one number to get C and D. It seems like a complicated way to understand it, but this is the foundation of algebra. So understand that. And that's what they're wanting you to use this information to multiply a ratio times a whole number to create a new ratio. So problem set number 1 says write 2 ratios that are equivalent to 1 to 1. So 1 to 1 is our AB. Use a different color. So 1 to 1 is our AB. And we're going to times it by C, some other number. So in this case, we'll say times 2. So our little c equals 2. 1 times 2 is 2. 1 times 2 is 2. So our new ratio, CD, is 2 to 2. 1 to 1 is equivalent to 2 to 2 because we multiplied both digits by the same whole number. So there's one equivalent fraction. Go ahead and create another equivalent fraction by multiplying 1 to 1 times another whole number. Okay, read the questions carefully and answer them the best that you can to complete the homework page for Lesson 3.